All right, so I equals radical negative 1. Then we get up to I squared, we get radical negative 1 squared. And because the radical and the squared are opposites, or inverse operations, then you're left with negative 1. Whenever you have I squared, you simplify it to get negative 1. Whenever you have this, you don't write that, you write I. It just stays as I. Okay? But it's good to know what it equals. Look down at the next one. Now I'm going to kind of do some manipulation here. Here's some exponential... No, not exponential law. Oh, laws of exponents. Can I write this? Is this allowed? Now, I wrote the 1 there just to kind of help you out, but we normally don't write the 1. Yeah, it's allowed, right? Because when you multiply those two i's together, you add the exponents. Now, do you guys know what this equals? Yeah, that equals negative 1. So we have negative 1 times I, which we would just write as negative I. So we're going to we just have to do one more, because everything else starts repeating what we just wrote down. Here, last one. What do you guys want to split that one up into? Yeah, I squared and I squared. I squared times I squared, that equals negative 1 times negative 1, which equals uno. Alright. Now, when you start, when you really, really understand this, and you start looking at it, and you get to these crazy ones that look like this, that say something like, I raised to the 16th power. That's the same as I to the 4th times I to the 4th times I to the 4th times I to the 4th. And what does I to the 4th equal?
1.
So it's like saying 1 times 1 times 1 times 1. If it's divisible by 4, then you know that it's going to equal 1. You guys got that? Let's check out another type of even number. Because even numbers, they're either going to be divisible by 2 or 4. Some of them are, a lot of them are divisible by 4. So what about this one? Is that divisible by 4? No. And so what you would do is you would go I to the 4th times I to the 4th times I to the 4th times I to the 4th. Oh, I should have just wrote I to the 16th. Dang. And then the last one you go I to the 2nd power. Right? Because I to the 16th, dang it, 16th times I to the 2nd, that would equal I to the 18th. Right? And what is I to the 16th? That's 1. And what is I to the 2nd? So you have 1 times negative 1, which equals? So if it's divisible by only 2, not 4 also, then you know it's negative 1. Oh, but what if we get odd numbers, Mr. Patey? Like I to the 9th power. Alright, so I moved them up so you guys can see. Alright, so we have I to the 9th. What would you want to split that up into? Yeah?
I to the 4th times I to the 4th.
Oh, he totally stole your fire, dude. I'm sorry. I to the 3rd? That way works too. But don't you like one's better? You can split up I to the 3rd, I to the 3rd, I to the 3rd, because we know what that equals. It equals this guy right here. But I to the 4th equals 1. Oh, so much more pretty, right? So if I go I to the 4th times I to the 4th times I, will that give me I to the 9th? Faux show, because 4 plus 4 plus 1 is 9. So we have 1 and 1. And what's... Oh, it's just I. Beautiful. Yeah? Yes? Question?
What is this for? What is I? What is this?
I is an imaginary number. We already went through this.
What are we going to use it for? Yeah. We were dealing with...
My classmate. Okay, so now let's say we have a different type of odd number like 7. Why is that one different? Well, because if I split this one up with a 4, I'm left over with 3. So I did a 3rd. While this is a 1, what is I to the 3rd equal to? Negative I. So you multiply the 1 and the negative I, you're left with negative I. I guess you guys will get more and more practice with this the more you guys see problems. Okay, now write this down. This guy's really important. This guy is the standard form for a complex number. A is your real number, and B is the imaginary number. That's a complex number. A plus or minus bi. It is a standard form. Now, you don't always have plus or minus there. I'm just saying it could be a plus bi or a minus bi. Let's check out some problems with it. Okay, actually I don't want to do these ones. Alright, so normally before, even when you try to simplify these, you can't do it because of the negative in there. But now you can take a negative 1 out of it, so it'll be negative 1 times radical 32. So rad negative 1 times rad 32. The next one, what is radical 25? Oh, 5. That one simplifies easy. Okay, now this one right here, we're trying to simplify it. We'll have to take out the negative 1 so that we can get crazy with it. So let's look at the 32 first. Do you guys remember how to do this? You have to look at the 32 and ask yourself, is there a perfect square that divides 32? Yes. 4. 4 divides it, right? What else? Is there a bigger one? 16. You want the bigger one. And if you do the 4, it's not bad. You're just going to have to do it again. But if I take this and I split it up with a 16 and a 2, I can start simplifying things. Now, then it says minus 5, then plus whatever's over there. Okay, we'll get there in a second. Staying right here, let's simplify that. What's another way to write rad negative 1? I. And what's another way to write radical 16? 4. And then can I simplify this? No. So it's 4i radical 2 minus 5 plus. Okay, now let's do these guys. What would I split up the 18 with? Okay, I'm going to change the radical negative 1 right away. So it's rad 9 times radical 2. Rad 9 is 3. So we have 3i radical 2. Is it simplified? No. You got to look at the I and the radical 2 like it's a variable. Like it's a big X. So that means you're going to have to combine like terms here. The negative 5, nothing happens to him. But this guy and this guy are like terms. When you add those together, you get 7i rad 2. Look at the I rad 2 like it's a variable. The next one, this is what might happen sometimes when you guys are solving quadratics. If you're solving a quadratic and you get a negative inside of the radical, it'll look like this. So you'll have 9 plus or minus. And now we got to start simplifying that. So we got negative 1. We take the negative 1 out. And then what we want to take out of the 72. Is there a perfect square that divides 72? 9. 9 does. But let's see what we get. When we divide that by 9, we get 8. Oh, look. We can take another perfect square out of 8. So it looks like we could have taken a 16 out. Not a big deal. So we have we'll just go radical negative 1, radical 9, radical 4, and radical 2. Do you guys see where I got the 4 and the 2? Yeah, I got it because I split up the 8. So this is a I, that's a 3, and that's a 2. 2 times 3 times I is 6I radical 2 over 3. Is this simplified? You have to divide the 3 from both of them. So when you divide both of them by 3, you get 3 plus or minus 2 I rad 2. Now this looks closest to our standard form, which was A plus or minus BI. This is a standard form for a complex number. It looks really close to it, but it's not it yet. This I needs to be right there. So it's 3 plus or minus 2 rad 2 I. Standard form. Does it really matter? No, because this is 2 times rad 2 times I. It's still the same thing. It's just the looks. This is just an example out of the book. Okay? I wanted to pop it up here just so you guys see it. I thought they did a great job. You can check it out. It's just like combining like terms when you guys are doing polynomials. The only thing I wanted to point out is don't forget when you have a subtraction to distribute that before you add them together. Okay? This is also in the book. For this, I wanted to show you guys and point out when you distribute these, when you get the I squared, you have to simplify that. The I squared gets simplified. See, they even say it right here.
that you need to make sure that you simplify it, because I squared equals -1. So here's an example that you would have to distribute to simplify. So we'll go see 2 times 4 is 8, 2 times 3 is, or 3i is 6i. Negative I times 4 is negative 4i. And then negative 1i times positive 3i would be negative 3i squared. Here's your I squared. So we have 8 plus, 6 minus 4. It's just like as if I was an x. You treat it like it's a variable. So it's a 2i. Then this is going to be negative 3 times negative 1, because that's what that's what I squared equals. Negative 3 times negative 1 is going to be a positive 3, so I put that right there, and positive 3 is going to add with the 8. So we have 11 plus 2i. We have the imaginary number second and the real number first, and so there is the answer to that one. One more thing to know about the complex numbers is if it's in a fraction like this one, you have to do something with it so that you don't have an imaginary on the denominator. So in order to do that, we go to the idea of a difference of squares. So like for example, let's say we have 3x plus 5, and we multiply that times 3x minus 5. This will give us a difference of 2 squares. If we multiply this out, let's say it'll be 9x squared, and then minus 15x, and then 15x minus 25. You know, from multiplying the 5 out, that's what we get. And you'll notice that the middle term with the x cancels out because they're opposites of each other. So you have 9x squared minus 25. Well, you can imagine if I didn't have an x right here, and instead of having an x right there, I had an I. That means right here you would have an I squared instead of an x squared. And an I squared simplifies, well, it changes to, it can be replaced by a -1, then the -1 will multiply to 9, and then there'll be no more x down here, or variable down here on the denominator. So here we have 4 minus 2i. Now, in order to multiply it by its conjugate, you could multiply it by a negative. You can multiply it by 4 plus 2i, or you can multiply it by negative 4 minus 2i. You just have to change the sign of one of these. Either you're going to change the sign of this guy, or you're going to change the sign of this guy. Now, normally we're going to change the sign of the second one just because it looks nicer to have a negative or a positive in the middle than to change the sign of the first one. So I'm going to multiply the top and the bottom by the conjugate. That's 4 plus 2i. And I'll multiply the top first, and so for the top I get 8 plus 4i from multiplying the 2 to both of these. And then I'm going to get 12i plus 6i squared. Now here it's not a difference of squares, so these are not going to cancel out. And so the numerator is going to have, let's see, an 8 plus 16i, but that 8's about to change because this 6 with the I squared on it is going to change. The I squared becomes a -1, so it's 6 times -1, so it's going to be a -6. So this is a -6, and that combined with the 8 is going to be a 2. So let's get rid of that. We'll make that into a 2, and that's our numerator. The denominator, because we know that these are, it's going to give me a difference of squares because this is the conjugate. You could do a shortcut. You can go straight to 16 minus 4i squared. Now, if you're still kind of not understanding how I got that, then you need to multiply it out like I did this one right here, and you'll see that the two middle terms will cancel out. Then this is going to change because the I is a -1, so we have a -4 times a -1, so that on the bottom I'm going to have, let's see, that's going to be 16 plus 4, which makes 20. So on the bottom I'm going to have 20. On the top I have 2 plus 16i. Now to write it in standard form, I have 20 divided by, or 2 divided by 20, plus, the plus is from the 16, I'm just splitting up this fraction. And to split the fraction, the denominator stays the same, it just gets repeated. I'm sure you guys remember that. And then I have the 16i up top. To simplify, the first one I could divide the top and bottom by 2. And for the second one, I'm going to take that I and put it after the fraction. For the second one, divide the top by 4 and the bottom by 4. And then the I is right there. And we write it like that because this is standard form. You can see your real number and your imaginary number. And that's your answer for that one.